Welcome. In this video, I'm going to go over an example of how to apply the chi-square goodness of fit test. So let's go ahead and read through the problem together. A professor at Anytown University, Ms. Mathface, is teaching one section of calculus, one section of statistics, and one section of linear algebra. This professor, she's interested in the preferences students have for the various textbook formats. As Ms. Mathface uses only open source textbooks, students are able to choose to purchase a hard copy from the campus bookstore, read the text online, or print out the pages from the textbook. She predicts that 25% of her students will purchase a hard copy of the book, 60% will read it online, and 15% will print the pages from the web. At the end of the semester, she asks her students to complete a survey where they indicate what format of the book they used. The survey results for those of you in my Canvas course can be found under the Data Sets tab in StatCrunch. And this is the name of it. Conduct a goodness of fit test using technology to determine if Ms. Mathface's predictions are statistically inaccurate. Well, first let's begin with our null and alternative hypothesis. But before we can begin those, we need to just tease out some numbers from this. And there's a lot of extra information given here. So what information do we actually need? Well, she's interested in the preferences of students, their preferences for various textbook formats. So here are the formats we have. 25% of students will purchase a hard copy of the book, 60% will read it online, and 15% will print out pages from the web. So I can call the hard copy proportion P of H, and that's 0.25. Now let's call the read it online group P sub R, and that's 0.6. Next, there's the print pages group of students. And they are P sub P, I'll say, and that proportion is 0.15. Okay, so the null hypothesis is that these proportions are true. So we can do this symbolically or with words, and I'll do both. So P sub H equals 0.25, and P sub R equals 0.6, and P sub P equals 0.15. So this is in words. Let me make a little bit of space. This is Ms. Mathface's predicted distribution is accurate. And now the alternative is that at least one of these does not equal her predicted proportion. So P sub H is not equal to 0.25, or P sub R is not equal to 0.6, or P sub P is not equal to I keep wanting to write 0.5, but it's 0.15. There. And in words, Ms. Mathface's predicted distribution is not accurate. Okay, so with that, let's go ahead and open StatCrunch. Those of you in my course have access to this data set in Canvas, and here's what it looks like. So let's start by labeling some columns. We need to create a bit of a table. So I'm going to write format here. I'm going to write expected and observe. Now under format, let's go ahead with hard copy. Next is read online, and then print pages. And this matches up with what we wrote by hand. And now our expected proportion of students who purchase a hard copy is 25%, so 0.25. Our expected proportion of students who read the text just online, no hard copy, no printing, is 0.6, so 60%. And the proportion of students we believe will print the pages is 0.15. Now for our observed. So the hard way to do this would be to go down this column and count one at a time. 1 online, 2 online, 3 online, 4 online, 5, 6, and don't do that. That's me being silly. Don't do that. Look at this. There are 101 points of data here. So no, let's not do that. Let's get technology to do this for us. So go to Stat, Tables, select Frequency. And there we go. I need to resize this so it's visible on the screen. There we are. And text format. We're interested in counting up how many students use which format of book. And frankly, I only need the relative frequencies here. So I'm just going to select relative frequency and compute. And there it is. So now for my observed proportion of students who have a card copy, I'm going to just go ahead and highlight this. Command C on my Mac to copy. I think it's Control on your PCs. And then paste with Command V. So Command or Control depending on your device. Command C, Command V for online. And then again, I'm going to highlight, click Command C, and then Command V. Now let's go ahead and do our actual test. Let's go here to Stat, go to Goodness of Fit, and let's select the chi-squared test. And now we named our columns well. Actually, here we go. Now we can see everything of interest. We named our columns well, so our observed is actually named observed, and our expected is under expected. So see, if you're not in my online course, you could have easily followed along by just going ahead and typing in these numbers in your own version of StatCrunch to do this test. Let's go ahead and click compute. Okay, and now that is what we need. So I want that, or this information here. All right, so we're back now, and here is what we've done already. We worked out our expected proportions. We wrote out our null and alternative hypothesis using symbols and in words. And here are the results. And we're really interested in the p-value here. I thought this was highlighted, so I'm going to go ahead and highlight it again. For no reason other than if you highlighted your paragraph to match, I would like these colors here to still match. Okay, so let's look at this p-value. We were not given a significance level, but really that doesn't matter. This p-value is really larger than any useful significance level. So the p-value of 0.9898 is large enough, and this is for any useful significance level, that we fail to reject the null hypothesis. Now for our conclusion, we failed to reject the null hypothesis. So that tells us that this data does not provide sufficient evidence for the notion of Ms. Mathface's predictions being statistically inaccurate. In other words, there is insufficient evidence to indicate that Ms. Mathface's predictions, her predicted proportions, are statistically inaccurate. Now, some of my English majors out there might be going, uh-oh, this is a double negative, professor. Insufficient, inaccurate. You are correct, but I can't just say there is sufficient evidence to indicate that these predicted proportions are statistically accurate. All I can say is we failed to reject the null hypothesis. We kept it. And we started with the assumption that this hypothesis here is true. So we're just keeping our assumption. Okay, keep calm and math on.